All right, hi everyone. Today what we're going to do is called compound interest, okay? So compound interest. And the idea of an interest is you gain a little bit of money based on your investment. So let's go for something called simple interest first. Simple interest. Simple interest is, let's say you put $100 in the bank and I promise you a rate of 5% per year. So after 1 year, how much would you have? So we take our calculator and we say we start with a principal and we multiply by some type of rate, and then you end up with your, I guess your, how do you say this? Your profit, I guess, or your interest. Oh, sorry, interest. Haha. Okay, we take our principal. P is for principal. Principal is how much we initially invest. Our rate is at what growth rate are we going to have? So when I do this, I write 100 times a percentage rate. It's 0.05 equals to an interest rate is, if you guys have a calculator or you can figure out what's 5% of 100, $5. Great. And now you would have to go back and say, well, how much would I have in my bank account now after 1 year? If I made $5 in my bank account, you have to go back and add 100 and $5 together to end up with 105. Okay. But is there a way for us to skip this step? Can we skip this step here on the right? Well, yeah. Instead of writing just 5%, how much are we actually multiplying? We're actually multiplying by 105%. So here is the other way of looking at it. We have our principal times a rate of 1 plus R is equal to my total, okay, all my money. Okay, so we're going to change this simple interest, this idea of the simple rate, and we're going to try to make it a little easier for us to use. Because if I have my principal of 100 now, and I multiply that by 1 plus 0.05, this becomes 100 times 105%. That's 105%. And if you plug this in your calculator, you can multiply this by 100. That's $105, which is a faster way than us doing these as separate steps. You can do this for a lot of things. Let's say you're trying to calculate how much tax you're going to pay when you buy something. The tax rate in LA is about 10%. So if I'm trying to spend 50 bucks, so let's say tax, we can say it's $50 times some rate, and the tax rate is 0.1, which is 10%. 10%. If it's 10%, well, what's 10% of $50? Unfortunately, that is $5 that goes to Uncle Sam. Well, great, $5 to Uncle Sam, but we could say, hey, how much would you owe total? How much would you owe total? Instead of writing this 5%, let's do this instead. We do $50 and we multiply by 100, 1 plus 10, 1 plus R, which is 50 times 1.10. And now if I multiply that in my calculator, 5 times 1, 5 times 1, we see that's 55. And the 2 zeros kind of bump us over, okay? $55. So depending on what you're looking for, am I just looking for that interest, that extra rate, or am I looking for my total bill at the end? Which one are we looking for? And I'm trying to make my life a little easier, so I'm going to look for my total value at the end. So I'm going to use a 1 plus. And that's kind of that hint. Here's something kind of interesting. When you go to a restaurant and you eat at a restaurant, let's say you're going with a bunch of friends. And this is something that you're doing a lot in college. And as you guys are juniors and seniors, when COVID's over and we start to open up some more, you're going to go hang out with friends, right? That's just a thing that we want to do. Now, if you guys have done this before, you go out and you have like 4 or 5 people and you all eat something and the bill comes and you all take out your money and you pay and you end up being a little bit short. Why are you a little bit short? You're all friends. It's not like you guys are trying to rip each other off. It's just that your friends suck at math. And why do I say it that way? Because let's look at a typical bill. A bill comes with some type of bill, right? We'll call that B, plus, so whatever you spend, the bill plus, what else do we have? We have tax, and we have tip. We have tax and tip. You have the bill, plus you have tax and tip. And people don't realize how much tax and tip is. Let me go ahead and give you an easy illustration of that. Let's say your bill was $10. Okay. How much do you think your friends will put down for tax and tip? Because you know they're all good at math, right? They'll put it like $1. Here's $11. Keep the change. But they don't realize that tax and tip is another, what's tax? Tax is 10% in LA, right? And isn't tip, if you want to keep with the norm, isn't also 10%? Nope, it's 15%, right? If you want to below norm here, right? So it's actually 25%. You have to contribute an extra 25% of your bill. Well, that's $10 times 25%, which is 0.25. And this is our overall bill. So let's go ahead and write this in a, we'll just do the math here. It's going to be 10 plus, what's 0.25 of $10? That's $2.50. So you would have to actually pay $12.50 if you went out to eat. Do you think your friends gave $12.50? Probably not, because your friends can't count. Maybe if they're generous, they'll give you 12. So why are you always short? Is because your friends can't count. So I have an easy way of counting. I say add a quarter for every dollar you spend. If you ever go out with friends and you have to collect the money for the bill, everyone must pitch a quarter for every dollar that you spend. So if you spend $10, guess what? You have to give 10 quarters. How much is 10 quarters? That's $2.50. Your friends can count quarters. They've been counting quarters since they've been children, okay? So if you can tell your friends to count quarters, you can do it. If you don't have change, round up, be generous. So if you don't have change, you're gonna give $13. And that 50 cents will cover maybe a friend that didn't have that money, okay? This is not a joke. So if you ever go out to eat, you're gonna give a quarter for every dollar, and that'll help you cover the tax and tip, and maybe a little bit more generous with your waiters and waitresses. Does this work for every case? Yeah, it actually does. What if you end up spending $12? Okay, so that means you need 12 quarters. 12 quarters is $3. Who would have known that you had to give $3 in tax and tip for a meal? Let's say a burrito and a soda. That's $15. Your friends aren't giving you $15. They're giving you $1. And then you end up short on the check. Oh, I paid. Okay, so take this rule of thumb. This is Mr. Coe's. I teach this to all my friends, and they're all like, "Wow." Okay, no joke. If you eat with a lot of friends and they always short you on the bill, this is why. Okay, so how can we make this into what we've been talking about, simple interest? Well, we have, let's say $10 that we talked about before, and we're going to multiply this by a rate. So this is our principal, and this is our rate. What's the rate? We're going to say it's $1 plus what? Plus 0.25. Why did we say it's a 1 plus 0.25? Is we're actually counting 125%. You got to pay the bill plus the tax. And that's actually represented right here. This is a 1 plus 1.25. If I factor out the 10, that's 1 plus 0.25. That's exactly what we've been doing. You get your original value plus the interest plus the rate, and then you combine those together. And this gives us 10 times 1.25, which gives us $12.50. What do you got to pay? Okay, tax and tip, no joke. When you eat out, it costs a lot of money. So now we can do this simple idea of simple interest. What if I ask you to now switch over to compound? What if I want you to switch it to a bank account? Let's say you have $1,000. Oops. $1,000, right? We all wish we had $1,000. So let's now go to compound interest. Let's say you have $1,000, simple $1,000, and you put in the bank, and the bank gives you a return of 3%. So you put it in the bank. So after 1 year, how much do you have? Well, you have 1,000 times 1.03. What I mean by this is 1 plus 0.03, which is 100% plus the 3% tip, 3% interest. So how much do you have at the end of the year? If you can multiply with a bunch of zeros, so you see the decimal point, we multiply and we bump it over, you end up with $1,030. Does that sound like a lot? Let me ask you, if you had $1,000 in the bank and you put it and you were hoping to make a lot of money in the bank, okay, because you're saving, you're being a good person, saving money for a rainy day, how much do you expect to make off that $1,000? Well, good job, you made $30. Is that a great return? Absolutely not. Right now, currently in our financial situation in the nation, our interest rates are actually below 1%. They're below 1%. They are like 0.75 or 0.6 of 1%. Okay, so you would make $6 off $1,000 if you kept it in the bank. Okay, so now let me ask you, what if you want to continue to leave the money in the bank, right? You're being a good steward. You're not using this money. You don't want to keep it in your couch, right? Because there's no way of, I mean, it doesn't make money in your couch, right? So what do we do? Well, now that we have $1,030 on my second year, we're going to get the same interest rate. So we're going to have 1030 times 1.03. Now, how much do we have here? You guys can get your calculators out and try this. I have 1,030, and we are going to multiply by interest rate again, 1.03. And we have 1,060.9. Now, I want you guys to notice, what happened here. So I took my last year's gain and I reinvested it. So just to show you what happened, I'm going to make $1,000 worth of interest. And for $1,000, don't we make $30? And then we made interest off the $30, and that we made 90 cents off it. Yay, 90 cents. You made money off your money. So not only do we make our 30 off our initial 1,000, but we also make interest off our interest. It's like having children, right? You have children, and what do these children do for you? They go out and make money for you. And if they have children, they're gonna make money for you. So we're making money off our money. Okay, let's do this again. Let's do this for a third year. We have now 1060.90. And we're going to multiply this. This is now my third year. 1060.90. And we're going to multiply this again by 1.03 for our third year. So we take your number and we multiply by 1.03 because for 3%. And guess how much? Give me a guess. How much do you think you would make? Well, don't you make $30 off the 1,000? And then now that you have two 30s, you would make 90 cents off each of them. Plus you have money to make off 90 now. So you're making money off every little nook and cranny possible. And we now have $1,092.73 rounding up. So not only are we making $30 extra every year because of that initial $1,000, but then we're making a little bit of change, right? We're making a little bit of change here off our interest. Okay, so we're making a little bit of money off our gains. And this is super important because this is how you kind of make your millions. You take your winnings and you reinvest your winnings. You don't spend your winnings, right? If I went and I took them $30, yeah, I'm gonna go get some lunch now. I wouldn't have made this extra 90 cents. You might say 90 cents isn't a big deal. You know what, you're right, 90 cents is not a big deal. But what if it wasn't 1,000? What if it was 10,000? That would have been $9. What if it was 100,000? Right, that would have been $90. Okay, so our interest off our interest adds up. And this is what we call compound interest. Now, if I ask you to continue this pattern for, let's say, 10 years, would you agree this would pretty much fill up the whole paper? So instead, I want you to be a little smart here and take a look at each step. What did I do? At each step, what did I do? What was the same thing I did at every step? On my first step, we started with 1,000, and didn't I just multiply 1.03? And then we took our same answer, and then we multiplied it again by 1.03 to get to my second year. And then we did the same thing again. We took our answer, we multiplied that by 1.03 to get to my third year. So to get to 3 years, how many times do we multiply 1.03? 3 times. And we want to talk about exponents here. Exponents is a fast way of multiplication. So instead, here is our overall rule. For 3 years, we took $1,000 to start, and then we multiplied it by 1.03 once. We took this answer, and we multiplied by 1.03 twice. And then we took this answer and we multiplied by 1.03 again, right? Now, talking about exponents again, exponents is a fast way of multiplication. So do we multiply 1.03, 1.03, 1.03? So our fast way of writing this is 1,000 times 1.03 to the third exponent. Okay. Now, if I wanted to get 10 years out of this problem, how do you think I would do that? For 10 years, what do you think would change? Would the initial change for 10 years? Is the interest rate changing for 10 years? Or is the time changing for 10 years? And hopefully you're realizing the time is changing. So it's just 1,000 times 1.03 to the 10th power. So if that's the case, okay, let me just re-explain it. If I'm doing 10 times, we start with 1,000, and then we multiply this by 1.03. And then we take this answer and multiply by 1.03. And we do this all 10 times. And do you want to do it 10 times? It would take us forever, right? I mean, it's possible, right? But I don't want to do that. And so we end up with this situation here. We can just know what, just give yourself an exponent. Now let's try it on your calculators. Let's see if you guys can do this on your calculators. If you can type this on your calculators and type in the chat once you get the final answer, tell me how much have we made in 10 years. You can put it on direct messages, or you can send it to me directly, but let's see if you guys can write this in your calculator. On my calculator, I'm going to write 1,000 times 1.03 caret caret to the 10. That's how I'm going to write it. If you guys have a other calculator, nicer calculators, you might write 1,000 times. You have a little key that says x to the y, and then you can write the number 10. Okay, I'm getting I'm getting actually a couple answers now. I'm getting 1343.92. That looks pretty good. So I'm going to type it on my calculator here. Just double check 1,000 times parentheses 1.03 to the exponent of 10. And you guys are great. You guys ended up with a total after 10 years. This is how much we have total. We have 1,343.92 rounding up. We were able to figure out how much we make after 10 years. Now, let me give you another way of looking at this. Let's say your parents are trying to save for college. So right when you're born, they got a bunch of money as gifts, and your parents went and they put that in the bank, not investing in a way that they didn't put it in some stock market. They didn't buy Tesla. They just went and put it in the bank. So from age 0, and we wait 18 years later to you need the money for college, how much would we have? So let's use the same exact example here. And if we start off with $1,000, okay, and we give ourselves a nice generous interest rate of 3%, over 18 years, can you guys now tell me how much would you guys have ready for college? So if you guys could type that in your calculators and let's see what you guys get. And is it going to be that much different to get from 13,000 to what? We'll wait another 8 more years. Is that going to change? Thank you very much. I see a lot of you guys are coming up with a 1702.43. Perfect. Is that enough to pay for college? No, you didn't even really double your amount, but here's a crazy plan that your parents might have done already for you. They might have saved maybe $1,000 per year. So this year, right when you're born, you have 18 years. And then when you're 1 year old, when you're 1 year old, right? 1 year old, you have the same amount. So they put in another $1,000 and 1.03, but then you have 17 years of interest to come up with. And then the next year, when you're 2 years old, they put another $1,000 and 1.03. And now you have 16 years of interest. And you can see the pattern here is that as long as you consistently put in money, sure, you might not have 18 years of interest, but you have 17, 16, 15, 14, you have 10 years of interest rate. And at the end, after 18 years, you're gonna have some money, okay? And this is a way of people saving, right? If you wanna buy a house, that's what you do. Now, if you had went ahead and let's say, put your money in the stock market, and the stock market has grown over how much on average over the last 18 years, that's a different interest rate. So I just looked it up, and the stock market on average has gone up about 6% per year, not 3%, 6%. So we're going to change this problem. And I want to ask you guys the same situation though, except instead of your parents putting in the bank, they put in the stock market. And they say on average, they didn't buy Tesla, just on average, the stock market grew at a rate of 6% per year. Your parents still start with $1,000 to start. This is our principal. And our time is T is going to be 10 years. Oh, no, sorry, 18 years, okay? 18 years. Average rate of 18 years. Okay. So let's see how much money you would have. The interest rate doubled, okay? We went from 3% to 6%. Let's see if that's a big change. So let's set up. A is equal to 1,000. 1.06, because we're adding 1 plus the rate, 0.06. And we're going to stick 18 there. Can you guys do this calculation for me and tell me how much money would we have after 18 years at 6%? This is double the rate, okay? Are we expecting double the growth? Let's see, 1,000. Remember, this is being compounded. Oh, the number looks crazy. Oh my gosh, Aiden, you got it. 2,854. $2,854.34. You almost tripled. Ran out of space. I almost tripled your money. Isn't that really good? Right? If your parents put $10,000, and some of you guys, your parents got $10,000 because you were born, okay? Because your family's just super generous. They would have gotten $30,000 in returns. That could have paid for your first year of college, at least at a UC. And then the next year, fine. What if this was just 1,000 one year, and then the 1,000 next year, and the 1,000 the next year after that, 1,000 next year after that? You would have, I would have to do an Excel sheet for this, but you can see that we could be making a lot of money. We could have saved a lot of money. Okay. So what is a general equation for us to talk about simple compound interest? This is our general equation. So this is compounded one time a year. Our versus compounded n times per year. So my writing is a little terrible. N times per year. Okay. Let me rewrite that. N times. So we're gonna look at two different equation setups today. And one is just simply one time per year. And we're going to look at the more intricate one that we can use as a general formula. It's going to be our A is equal to, so this is our all our money. You can think of this as all our money, is equal to P for the principal, 1 plus R to the T, where T is the number of years. T is a number of times, really. How many times are you going to get this payment? R is our rate, P is the principal. This is our rate, and T is time. And in this case, is time in years. And this is the one we've been using repeatedly. And this is a great formula to use. It's super easy to use. Now, what happens if I'm using compound n times? A is equal to P 1 plus R over N to the NT. A lot of people see this and they're like, whoa, 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 what's going on here? When I say n times is instead of paying you once a year, what if I paid you every 6 months, right? Instead of waiting for the end of the year to pay you out, I'm going to pay you every 6 months. Now, why is that helpful? Let me go ahead and put labels on this. P is still the principal. R is still the rate. But N is the number of times per year. The left one is the easy way. At the end of 1 year, let me draw you a little graph here. Here's my first year, year 1 year. And second year. Let me draw you the same thing over here. 1 year, and then my second year. Okay, so the way this works is we have a starting value, P, right? That's our P value. This is our P value. That's our P value. Yay, we have money in the bank. But that money does not change till the end of the year, and then you get a bump. And then we can make money off that bump. So you can't make any extra money till the end of the year. And after the first year is over, you have extra money, then you can apply interest to that new amount. But what if I pay you every 6 months? So this is my 6 months chart. So is it 6 months every half a year? Let's take a look here. So after my first 6 months, you're going to pay me, and I have a little bit of interest now. And then I can make money off that interest. Every 6 months, you're going to pay me out. I'm going to make a little bit more money off that interest. So this is our initial P. So you're going to get your interest is your principal plus interest. And then this is your principal plus interest plus your interest on your interest. And this is a principal plus your interest on your interest plus your interest again. So you're making a little bit more money because you get that money in your bank account more often and they can pay you more often. So I can pay you out every single, I can pay you every 6 months. I can pay you every month. I can pay you out every day. I can pay you out every hour. I can pay you every second. I can pay you continuously, which is our goal in our next lesson. So which one do you get paid more? The more often you get paid, the more time you have to sit on your money and gain interest on it. Let's give you an example of allowance. Imagine if your parents said, I'm going to give you allowance once a month. So on the first of every month, they give you your big chunk of allowance. Okay, you can't do anything to get that big chunk of allowance. What if your parents say instead, I'm going to give you allowance every week? Now, over the first week, you might get less money, right? But that first week, couldn't you buy some chips and then resell them at school? Couldn't you reinvest that money yourself? Couldn't you buy some Pokemon cards that first week and then resell them? Right? You don't have to wait till the end of the month to start making money. You can make money after every interest payment. And that's why the compound interest n times makes you more money. Now, here is something I want you guys to show you. These actually are the same equations. These are the same equations. If n was just 1, what if I paid you not 3 times a year, not 4 times a year, not 6 times a year? What if I pay only 1 time a year? Are you okay that this n would be 1 and this n will be 1? R divided by 1 is just R, and t times 1 is just t. So that's one thing we want to say. If the n is just 1, means I pay you once a year, you can use the equation on the right, but you just write 1 instead. Now, why is the n even there? It's because if I tell you, let's give you this example. If I say I am going to pay you twice a year, let's use a T for twice a year. If I ask you, I'm going to pay you twice a year, how many months would each payment be? There are 12 months in a year. If I pay you twice a year, would you be okay? This is 6 months per payment. So how would that change my equation? Well, if I'm paying you at 5% per year, does these words match up? Does 5% per year match up with every 6 months? So am I going to give you 5% the first 6 months and then 5% again the second 6 months? Answer is no. I would divide the interest in two. So on this example, I would say 1,000 times 1 plus 5%. That's my rate. I'm going to write this as a decimal though, 0.05. And then I'm going to divide that by how many times is this 6 months, is twice a year. That is by 2. I'm going to divide your rate by 2. So really, I am paying you 1 plus 0.025% interest. Okay. And then our NT is going to be 2 times 1. Okay. Because we're talking about just over 1 year. And you can see these values n. Let's go take a look. Looking at my original example here, the n is on the exponent. Oops. N is on the exponent and is on the denominator there. Okay, so this is where the n goes. And I want to simplify this for you so you guys can see that this is actually the same equation. 2 times 1 becomes twice. So let's read what happens here. I pay you not 5%. I'm paying you 0.25%, 0.025, even smaller. But guess what? Instead of only paying you once a year, I'm paying you twice a year now. What if I want to pay you 4 times a year? Let's go ahead and change this problem for 4 times a year. 4 times a year. And then we call this quarterly. I'm going to pay you quarterly. So it's 1,000 times 1 plus 0.05 divided by 4. But I'm going to pay you 4 times per year now. So you can write this on your calculator. You can practice typing this on your calculator. To type this in your calculator, it will be 1,000 times, open parentheses, 1 plus parentheses, 0.05 divided by 4. Then you're going to close your parentheses. And then you're going to do the XY key, XY, and you're going to hit the number 4. Okay, this is how you would. This is the calculator version. This is what you would type in your calculator. And what's really happening here is we are saying you're taking paid $1,000. Sure, 1 plus 4 divided by 5 is 0.0125. So if you can see, the interest rate is actually even smaller than 0.25. But you get paid not twice a year, you get paid 4 times a year. So those interest payments do add up. Okay. So you might get paid more, but you get paid smaller pieces. But you hold the money longer. And you can make money off your money. Another version of this is, imagine if I told you I'm going to pay you your interest rate every 2 years. Do you really want to wait till the second year to get your money back? No. But what if I pay you every 1 year? Sure, I can ask you to cut the rate in half, the interest rate in half, and just pay me every year. So you can make more money on that second year. You don't have to wait till that second year to make it. Okay. Now, these aren't hard problems. When you look at problems when they ask you to set it up, that is not a hard problem. The hard problem is when they ask you these weird questions, like this. Let's come up with one question. How much would I have to start with to have $60,000 after 18 years at 5% interest? This question here is a hard question for us to get started with, but we have everything we need to go at this problem. We have everything we need. We're going to use a compound interest. No, we're going to use our simple interest rate or simple interest, because I didn't say I'm going to pay you guys quarterly or annual, semi-annually or monthly. So we're going to use this equation. A is equal to P, 1 plus R to the T. That's if we have all the information that we have. We have a time. The time is 18. We have our final value you want. We want to make 60,000. We have a rate of interest. So we have all the variables except for P. And the P is the question that we start off with. Hey, how much would I have to start with? That's our principle. Let's go ahead and fill in all the blanks. We have 60,000, that's my goal. And this is actually a great question to ask yourself, because you want to go to college and college is going to cost 60,000 per year. But how much would I have to start saving just to pay for that first year of college? 1 plus R. R is going to be 5%, and not 0.5. That's 50%, 0.05. And then the T value is going to be 18. Now for this problem, I want you to realize that all this here, though it looks ugly, that's just a calculator problem, right? 1 plus 0.05 to the 18th power, that's just calculator. And all we have to do for this problem is solve for P. And to solve for P, it's 60,000 divided by parentheses 1.05 to the 18. If you type this in your calculator, 60,000 divided by parentheses 1.05 to the 18th power, it would say I would have to start off with $24,931. That's how much I would have to start off if I put in just a one lump sum into the bank to get to $60,000 at 5% interest rate. So I would get to double my money in 18 years at 5%. If you end up buying Tesla, you do a lot faster. So that's one way for us to solve these. This is a super easy algebra problem. But if I ask you a different question, and this is the last question we're going to do. I'm running out of time. I'm actually out of time. But how long, if I ask you how long would it take to save $60,000 from $20,000? Okay, at 5% interest. Okay, so we have A is equal to P, 1 plus R to the T. We have everything we need. Let's see what we got. We got my final. We have our initial. Okay, we have our initial. And then we have our rate. But we don't have the time. And if you can catch this right now, why don't we have the time? Is because this is what we've been working on the last month. How can I solve for exponents? How can I solve for less than 0? 1 plus 0.05 to the T power. This is legit what we've been working on for the last month. What do we do? To solve for T, we get rid of everything else. Let's get rid of the 220,000 first. We end up with 60,000 divided by 20,000 is just 3. 1.05 to the T power. Now, folks, how do I bring down exponents? I get it, class is over. If you guys have to leave, you guys can leave. I'm just finishing up this last problem. I need to log both sides. Log of 3 equals to log 1.05 to the T power. Remember, the logs bring down the exponents. Log of 3 is equal to T log of 1.05. Divide the logs over. T is equal to log 3 divided by log 1.05. That's a calculator move. 3 log divided by 1.05 log equals, and it would take me time of 22.51 years, or 52 years, rounding up. Okay, and that's what you guys are going to be doing over your IXL today. And that's our main goal. We literally have gone through what our goal is for the last month, being able to solve for these crazy problems with exponents. Okay, that's it.